Hello, and welcome to another digital lecture for Salt Lake Community College. This lecture will continue to cover section 4.3 for Introduction to Statistics, comparing quantitative data across groups. There are several definitions in this section that you would like to feel comfortable with. You may want to pause the video to verify you have all the definitions correct. In this video, we would like to discuss how we can estimate the difference of two means. A good point estimate for the difference of means is the difference of sample means. To estimate the difference of two means, we will use the t-distribution. We could continue to calculate our point estimate, our standard error, our t-score, and p-value by hand, but we would like to use statistical software to instead emphasize the process and the interpretation of our results. So let us give a summary of the process used to test hypotheses about the difference of sample means. When performing a hypothesis test regarding sample means, we start by writing appropriate hypotheses. We must also verify the conditions required for using the t-distribution. Recall, if we had one sample, the observations must be obtained using randomization. They must be independent, or less than 5% of the population, and approximately normal. For larger sample sizes, we can relax the normality requirement. There can be moderate skew for sample sizes less than 30, and strong skew for sample sizes of 30 or more. If we're talking about two independent samples, each sample mean must separately satisfy the one sample conditions for the t-distribution, and the data in the two groups must also be independent. Again, if we were continuing by hand, we would compute our point estimate, our degrees of freedom, our t-score, and p-value by hand. But we're going to use statistical software to analyze problems. So let us look at an example so we can practice. The histograms below show the age distributions for separate random samples of leading actresses and leading actors in major motion pictures. Summary statistics for these distributions are also provided. We would like to test whether the mean age of leading actresses is younger than the mean age of leading actors using a 0.05 significance level. When looking at the distribution, it looks like leading actresses are younger than leading actors on average. Also, when looking at the summary statistics, it looks like the actresses do have a younger age than actors. However, is this difference due to sampling variability, or is there a real significant difference between these? Let's proceed with our hypothesis test. Our first step is going to be to state the hypotheses. Our null hypothesis is going to be that the mean age of actresses is actually equal to the mean age of actors. We would like to see if the mean age of actresses is less than the mean age of actors. This is our alternative hypothesis. When using GeoGebra, we are going to want to rewrite our hypotheses and compare them to 0. So an equivalent form for our hypotheses would be that the mean age of actresses minus the mean age of actors is equal to 0, and the mean age of actresses minus the mean age of actors is less than 0. Let's check our requirements for using the t-distribution. The data must come from 2 samples that are random. This is stated in the problem, that we're given separate random samples. The observations must be independent, or less than 5% of their respective populations. Here we are told that there are 84 actresses and 84 actors, and I believe this is well less than 5% of all leading actors and actresses in major motion pictures that we've created. So I'm going to say this requirement has been met. Both samples are normal, or the samples are greater than 30. Here we can see that our samples are not normally distributed, especially the leading actresses that has a strong right skew. However, since both of our sample sizes are 84, which is greater than 30, we can relax that normality requirement. And lastly, the samples are independent. Again, we are told that we have separate random samples, and there's no reason to believe that they are not independent. So we have verified the requirements for using the t-distribution. Let's continue with our hypothesis test now. We would like to compute the test statistic, the p-value, and then compare to our significance level. Now below you will see the GeoGebra output for computing a hypothesis test for 2 means. This is accurate. However, I would like to open GeoGebra and confirm this output together. So let's open GeoGebra. To perform a 2-sample t-test for the means in GeoGebra, we'll first open the probability calculator, and then open the statistics tab. Make sure to test for the 2-sample means. So we'll choose t-test for the difference of means. Now, our alternative, our null hypothesis is that our first mean minus our second mean is equal to 0. Our alternative hypothesis is that this was going to be less than 0. And now let's enter in our summary statistics. The mean for our first sample, and this will be our actresses, was 35.6. The standard deviation of 11.3, and there were 84 individuals in our sample. Sample 2 we'll use for our actors. There was a mean age of 44.7, a standard deviation of 8.9, and again there were 84 individuals in our sample. Notice that we are given our output. We're given a t-score of negative 5.79, and our p-value is 0. Now this may not be actually 0. It could be just rounded down to 0. But I believe this does confirm the output that we're given in this window. Now, because our p-value, which was 0, is less than 0.05, our level of significance, we will reject H0, reject our null hypothesis. So we reject H naught. There is sufficient evidence to conclude that the mean age of leading actresses is younger than the mean age of leading actors. Now let's look at confidence intervals. Again, there are several definitions here you would like to feel comfortable with. We could also continue to compute these confidence intervals by hand, but I would like to use GeoGebra to emphasize our results and interpretations. So let's look at this example. Again, you may want to pause the video to make sure you have these definitions correct. Here we are asked to compute and interpret a 95% confidence interval for the difference between the mean age of leading actors and the mean age of leading actresses. Again, the output for GeoGebra is given here. But I would like to confirm this is correct. So let's again open GeoGebra. And we'll go to the Statistics tab. And we'll check an estimate for the difference of means. Now, since we've already entered our summary statistics here, we can look at the bottom and we're given our confidence interval. The lower limit of negative 12.1999 and an upper limit of negative 6. And this is confirmed in the output that we have in our guided notes. So now let's give a conclusion in context of the problem we're looking at. We can say that we are 95% confident that the interval negative 12.2 to negative 6 captures the difference between the mean age of leading actresses and the mean age of leading actors. In other words, this means that on average, leading actresses are between 12.2 to 6 years younger than leading actors. This about covers all the definitions for section 4.3. If you have further questions, be sure to review the example videos that follow or ask your instructor.